So we're going to talk about a way to democratize DAOs through a novel voting method. That voting is called semi-reputation-based voting. But first, I would like to give you an outline of what are the problems that DAOs are facing right now. So also, I will say that I see democratization as a combination of two factors, both the participation of DAO members or just community members in voting, and also the low concentration of voting power. So first of all, the voting power. The larger the DAO, the more concentrated voting power is. So we can see that in the case of the largest DAOs, the voters with more than 50% of voting power made just around 0.1% of all the voters. So it's like the DAO with 50,000 members is controlled by 50 members. That's the kind of centralization that we're talking about. And so going forward, the voting power concentration comes not only from the concentration of tokens, it also comes from their indifference. So here we can see a quote from Lionel Penrose, where he said that when the indifferent population is very high, then even if the voting power concentration is, even when the voting power is not as much concentrated, then the influence of that group that actually takes part in voting, and that is predominantly the whales, have even more influence. So how do we actually help DAOs? So there are studies that support the thesis that voters with more voting power will actually participate if we just increase their voting power. We don't have to incentivize it further. We don't have to give them monetary rewards to participate in votes. If we increase their voting power, on average, they will participate in the votes more. So, let's also ask ourselves, why is one token of one vote so common if everybody knows that it does not work very well? And the answer is because project need to raise capital, right? And so if tokens don't have any utility, project founders can give it to these tokens by just making them a governance token, right? So that's understandable. And so when designing any novel voting methods, we don't want to exclude tokens. We want to retain these tokens as governance bearers, because that just gives them utility, and projects in Web3 need capital to hire devs and to do marketing and so on. So, like I said, and how do we measure reputation? That is another very important question. So that's the key innovation of the system that I will introduce to you, is that first of all, we know how to measure the number of tokens, right? Just number of tokens you have is the number of votes you have. But for measuring reputation, we can actually utilize rating system like ELO. So why ELO? For many reasons. One of them is because just like in chess, when there are many players, there's statistically the ELO is a good representative of the strength of a player, or the ranking of rating understood as how that player stands out next to other players when it comes to activity. For example, how often he participates in votings, how often he does some tasks that we want them to do, and so on. So we measure it very similarly. And here we'll just do a quick breakdown of the equation. So VP voting power, that's kind of obvious. Tokens, you just multiply by the number of tokens a player has, a community member. And so the C term looks kind of scary, but let's break it down. So C, base constant, this is just some number like 1.5. This can be adjusted. Z, this is the number of standard deviations a player is above the norm in terms of ranking. For example, if anybody of you played online chess, you know that you have rating, for example, 1800, right? If the average is at 1500 and 68% of players are below 1800 rating, then that rating is one standard deviation above the norm, right? So the Z factor, this is just the rating of a player minus average rating divided by standard deviation. So, yeah, that's the Z term. Now the other one. First of all, here we can see this inactivity damping factor. I mean, e to the minus gi times this factor. And what is this? And later we're gonna do an example, so this won't look, too confusing. This is just some constant, and this tells us how much we want to tolerate inactivity. So later, through example, we're going to see that the larger this number is, so larger is kappa to b, the more we punish inactivity. And the median is the number of activities, for example, number of played games by some player, by players that are of similar rating to the player we are considering and to the player that we want to punish for inactivity. For example, if we have a player with 1800 rating, then we want to look at players between 2100 and 1500 in terms of how much games they played, how much tasks they performed, and then later potentially decrease the voting power multiplication factor if the player that has high rating but didn't play too many games, didn't play too many games. No, because it can't go below 1. So the multiplication factor is 1 at lowest, or else it will be higher, So yeah, that's a good point. Basically, this inactivity damping factor goes here to the minus exponent of e, and the minus gi is the number of games the player that we're considering has played. So, for example, or maybe we're going to see an example here. All right, so you can have 10 seconds or something like that to maybe read through the defining variables. All right, so now let's break down what happened here. So first of all, number of tokens one has. That's something that is taken into consideration at the end of this equation. Skill is z-score. So like we said, how many standard deviations a player is above the norm. This is equal to 1. So if standard deviation of rating is 300, the average rating is 1500, then that player has like 1800 rating. The next thing, activity. Player played 25 games recently, and by games we don't actually mean games like in chess. We actually mean that player has performed 25 tasks. Like, for example, we have these airdrop tasks and other kind of tasks that we usually want players to perform, and that's what we're measuring here. And later I'm gonna talk about how do we increase and decrease the rating based on how player performs in these tasks. Then we have the damping factor. So this is equal to 0.1. And what this means is that in the previous equation, if the median of the number of games that players similar in rating played is 10, and the kappa is equal to 1, then then that's why the damping factor is equal to 0.1, right? And the base constancy, that's just equal to 1.5. That's something we set up initially. So here we have the calculate the logistic activity term. So that's something that will later decrease the voting power of a user if he has not played enough games. Something that's important is that the voting power will always be decreased to some level. But that decrease of voting power as the player plays more and more games will just go slower, as that's how this logistic function works. Then we have the exponent computation. So the what we just calculated here, the 0.924 times the number of standard deviations a player is above the norm. So that will later go to the exponent. The z is 1. And by the way, one of the cases where the voting power might be decreased below 1, the situation that we have to take care of is if the number of standard deviations above the norm player was would be like below the average. But we don't decrease the voting power in that case. And finally, we calculate the voting power. So 1.5. This is just the constant. The 0.924 is the exponent that we calculated in step 2. And we have the final voting power. So a player that is moderately active and has played more games than the median and is 1 standard deviation above the norm has his voting power increased by 1.44. And as you can see, since the Z factor, the number of standard deviations a player is above the norm, is in the exponent, that means that if the player was 2 standard deviations above the norm, then that number would be 1.44, like to the second power, right? And that voting power increase rises exponentially. So the reason why that's okay with us is because in ELO rating system, the number of players that are, like the very high number of standard deviations above the norm is small. Like that's the idea. In ELO system, like you can only be in the top 5% if other people are in the like low 95%, and therefore there's no risk of increasing the voting power of people too much. Okay, so one use case is GameFi. That's kind of obvious. In GameFi, you usually use the rating system anyways. Those are based on ELO, or for example, like on LeetCode2 or other systems that work similarly but are a bit more complex. And in there, you could very easily implement, the voting power multiplication and increase the willingness of people to take part in votings and decrease the voting power concentration by just implementing the formula that was mentioned. And there you already have rating, and therefore there is no complication in regards to implementing the system. The second thing is in the case of DAOs or other kinds of applications where you don't have simple PvP where players play against each other, they can actually play against some tasks. Just like in Leech's case, or like another online chess, or mainly online chess, the tasks that players do have a rating on their own, and that rating is on the same scale as the rating of players. And what that means is that we don't need to have player against player competition. We can have player against the challenge competition, and the assumptions behind the ELO rating also hold. And therefore, we can kind of gamify anything and increase the voting power of those who are active in regard to playing games or tasks or doing tasks on our platform. So properties of the system. First of all, it fosters decentralization while allowing the token to retain its governance utility. So we are still able to do, launchpad rounds and like seed rounds and sell to investors because the token still has value. The voting power increases linearly with it. The second thing, reputation is measured on a continuous spectrum. That means that the multiplication factor that is a result of having high rating and many reputation points can be anywhere from 1 to 10, 20, or whatever we set the constants to be. And that's as opposed to, for example, games like Counter-Strike where you have divisions and there's nothing in between, right? Here you can have any number in between that that multiplies your number of tokens. And what this means for us is that every player is rewarded accordingly to their level and to where they stand compared to other players. And by design, it is highly resistant to Sybil attacks. It's hard for players to create multiple accounts and farm, reputation points and play games and later hijack the governance for the reason that it would require for them to play many games, and there's the inactivity dumping factor that reduces their voting power if they have not played enough. So that will be difficult. And that's all from me. I will be happy to take any questions.
Okay, we have the first one. I guess my question is just how much more data has to be stored on chain, or like compared to the simple just like key value of traditional things like implementation. How crazy is it?
Yeah, sure. So it's not very hard. So the ELO rating system, there are many libraries in Python or in other programming languages. Or for developers, it's very easy to just implement them and assign everybody how the hardest thing to come with is, I guess, if it is not a GameFi, but just some other like platform that has tasks for players to perform and to assign ranking, is to just get into the ELO how it works and other rating systems that are already known, and just copy what Lee just did or these other chess websites, in the simplest form, and implement it, but not with chess puzzles, but for the any task that you want like crypto people to perform. So I would say it's not difficult at all conceptually, and with regard to implementation, it just requires developers to like read this 20-page long PDF about ELO, and that with regard to data stored on chain, the data does not have to be stored on chain. It can be, but you can store it like normally on cloud backend.
So if I understood it correctly, the main way to change my ELO as a voter is to perform against some tasks, not against some other voters.
Yeah, exactly.
So the idea of the ELO system, that it's a zero-sum system, if the competition is only against other players, against other voters, doesn't hold if you perform against tasks, because the ELO of the task drops, not the ELO of other players. Yeah, did I understand it correctly?
Yeah, but you can make the ELO of the tasks like drop even more than the ELO of the player that would, and like the rating of a player would increase less and less as he performs against very lowly rated tasks, so to speak. So the likelihood that the player wins against the highly rated tasks or loses against lowly rated is adjusted, if that makes sense. So in other words, players gain less and less points, or less than that they would against player, if they win against a task that would be rated similarly to that player. So
okay, but anyways, is there any way? Do you have any idea how the competition between the players, only between the players, can be implemented in the system, or is it only for competition against the tasks?
Yeah, definitely. So this came up as I worked as head of product for a GameFi project, where players would compete only against each other. The idea of competing against tasks came later. And in there, you implement the ELO system, like in its traditional. I mean, not the ELO, because ELO is a bit too simple, but the Glico too.
Okay, so the competition is not in the voting, but on the other layer, on some other layer.
Yeah, exactly.
That explains it for me. Thanks.
Perfect. Thank you. If we don't have any questions, then thank you, Kajetan.
Thank you.